Okay, so we have done all our pre-announcements, and we are going to, oops, we are going to talk about, we're going to have a short lesson on the way the three-way switches behave, right? So let's say, okay, we have the whiteboard going on right now. Oops, there. Let me get my pen. All right, what is a closed circuit? A closed circuit is, just as a reminder, let's say there's a power supply and there is a connection to a load. And in this case, we're going to choose a light bulb to be the load. Okay, that's the symbol of a light bulb, more or less. And all right, if we have the whole thing connected, we are going to have something that's called a closed circuit. All right, so the current, considering the conventional current flow as opposed to electron flow, and this is a DC power supply. So this is, I'm just going to explain that thing on a DC power supply. The current is going to flow this way here, and it's going to continue through whatever connections. It's going to go through whatever load is going to meet on its way, and it's going to return right back to the power supply. Now we're talking about a closed circuit, right? Now, when it comes to a short circuit, it is just if somebody did a wire, connected a wire from here to here, then the circuit would be shorted. So that's the idea of a short circuit. I'm pretty sure you got the idea, but I just thought I would just mention that. So that's short circuit. It's nothing to do with the length of the drawing that I'm doing here. And it's nothing to do with the length of the wires. Right. Also, there's an idea of a short branch and a long branch, but that has nothing to do with the short circuit. All right, and there's no such thing as a long circuit. All right. Okay, so now we have, okay, oops. All right, mouse. So now we have the idea of closing the circuit. So if we substituted this power supply with the alternating current source, it would be just like, and of course we can't draw. Why can't we draw? There we go. Now we can. If we had the alternating current source, of course we would have the same thing. Let's say there's a light bulb and there is a closed pathway. There's a closed pathway for the current to flow. Now, when it comes to an alternating current source, um, sometimes you're going to see explanations that the current is going to flow same as we did, mm, with the DC current source. But this is, let's say, it's just an instant of a moment, right? Because what we know is that in the alternating current source, the current flows this way and that way, and it changes all the time, right? So in North America here, we have a 60 hertz cycle. So it changes the direction every 60 times every second, all right? Because that we have 60 hertz, okay? So it's the same idea. The circuit has to be closed, right? But the current just goes like this all the time. That's the idea of the alternating current. The energy is still happening there, so that's the energy of that alternating current going back and forth. It is also going to make the light bulb light up or the load work, whichever way it has to work. Okay, so in North America we have 60 hertz, and in Europe and certain parts of Asia, we do have also something like 50 hertz cycle. It's just the way things are, right? And just as a little kind of a interesting thing I'm going to mention, so 60 hertz, okay? Now, when it comes to one, and I always hear that from people, people say 1 hertz. Okay, there's no such thing as one hertz. There's one hertz, because hertz is a last name of a person who was basically who introduced the whole world to the alternating current, frequent alternating current. So hertz is the last name of a person. So there's one hertz. There's no one hertz. Okay, just because I constantly hear that. Okay, now so we got the idea of the alternating current and the DC and the direct current closed circuit idea. So I'm going to introduce you to something that's called a three-way switch. What is a three-way switch? Remember when we had the when we had the switch, whatever that thing is here, and you're going to have 1, 2, 3 screw terminals. That's what makes it a three-way switch. Well, because there's 1, 2, and 3 ways of getting at the switch. And some of the switches are going to have, this is the mounting brackets, all right? And some of the switches are going to have a additional bonding terminal. So that bonding terminal is not counted, okay? Uh, um, Sometimes we connect the bonding terminal here and sometimes we don't. If it is, it's a good idea to connect it. However, in Canada, we don't have to connect that if we are dealing with a EMT or metallic tubing, because the metallic tubing on one side, so if there's a tubing goes to a box, okay, and that metallic tubing continues, goes to another box, and then continues, and so on. All right, so it's just in Canada, it is enough to connect the bonding or the grounding to the first box, and then through the metallic connection, that grounding or bonding continues, so we do not have to run a separate wire. And as far as I know, that in the States and in some other part of the world, you still have to run a wire and connect every single box to that wire. In Canada, we don't. What we do have, how this switch is grounded or bonded, is through the metallic bracket that is going to be attached to the metallic screw mounts onto the box, and that's how this thing is grounded in it's considered to be grounded or bonded in Canada, right? That might change. Don't know which at which point of time you're going to watch this video, so maybe who knows, it might change with time, it might not, but at this time where this is 2022, this is the way we're doing things in Canada, right? However, as I said, wherever you go, you have to comply with whatever the rules and regulations are imposed locally. All right, so here's a 306. How does it work? Three-way switch. Three-way switch. Let's get the idea of single pole, single throw. Okay. So here's a wire, here's a terminal, and here the wire continues. So here's the switch right here. This is our switch. And it has a single pole. This is the pole, and it can be thrown one way. It could be closed or opened, closed or open. So it makes it single pole right here and single throw right here. It just goes that way, right? Now, the idea of, let's say, single pole, double throw, okay, would be, here's a terminal, here's another terminal, and here's another terminal. Here's a wire, here's another wire, here's another wire, and here is our switch. And we have a single pole. Okay, so let's say here is the single pole right here. Now the single pole can be thrown into two ways, into either this terminal right here or this terminal right here. So it goes here, or it could be switched to that, either here or here or here or here. So that makes it single pole, double throw, because we can throw it two ways. Right? Now, when it comes to double pole, double throw, pole, double throw, well, we have two poles here, and they are interconnected. Right, so here's the wire, here's the wire, here's another wire, here's another wire, here's another wire, here's another wire. Here are terminals. Okay. So here is our switch. These two poles are interconnected physically, and they can be thrown into this here and here. Let me see. Let me just get into this terminal and here. And if you move that lever here, bang, those two poles are going to switch here and here. So that makes it double pole, double throw. Okay, so that's the idea of the designations. The three-way switch is a single pole double throw configuration. So let's clear the board and start again. Let's continue. So we have a, let's say, switch this way here. Here's the main terminal. Oh. All right. Again, I drew it the wrong way. Come on. All right, so here is, let's say, about here. Here's a terminal, here's a terminal, and here is a terminal. All right, and here is a pole. So single pole, double throw, it is a three-way switch. Let's say not too far from there, we have another switch, just like it, just like this one, but we're going to point it the other way. So we have a terminal, we have a terminal, oops, and we have another terminal, and also we have a pole. And let's say this one is switched this way here. So this terminal here from the common, so let's say this one is common because it just stays in one place, that thing never gets disconnected. Let's say we're going to call this thing a common terminal. And this one here is called a common terminal. So this common terminal can be switched into either this terminal here, or either this terminal or this terminal. So click or click or click or click here. Same thing here. It can click here or it can click here, here and here. So just if you had a switch like that in your hands and you know it's a three-way switch, how would you know? And if those things, if those terminals were not labeled, and if you had a continuity, if you had a multimeter, you would switch it to continuity, let's say, and that switch is not connected anywhere. It's just, you're just holding it in your hands and you have those terminals. It would just look like this. Just like that. Here's a switch. All right. And here is the mounting terminals. And you have a terminal here, you have a terminal here, and you have another screw terminal right here. And they are not labeled. How would you use your multimeter to find out which one is common? Any idea? A multimeter, you switch it to continuity meter, which basically tells you if things are connected. You get that beep, remember? How would you connect? How would you find out just by using a multimeter which one is the common? An idea? You can pipe in on voice if you want as well. Don't be shy. We have some people here. There's got to be somebody who is going to speak up. Nobody brave today? Or are you guys still sleeping? I know it's Monday and the class is at 8 o'clock. All right. Well, at this configuration right here on the left, if you connect a continuity meter between these 2 points, what value of an ohm meter you're going to get, or are you going to get a beep on the continuity meter telling you that these things are connected? So are we going to say, are we going to get 0 ohms there, which means we're going to get a beep on the continuity meter? Yes or no? Yes. All right. Okay. So now we know that at least one of these two is common. All right. Now, what if we connected to these two? Are we going to get continuity? No. Good. You guys are smart. Of course, we're not going to get continuity. So, okay. So now we know that this one is not common. So it must be this one, right? And then just to confirm, you can continue, you can connect the continuity meter between this terminal and flip the switch just to make sure that this is the common. And if you keep flipping the switch and keep adjusting keep repositioning the other lead of the multimeter, you are going to find that this one is common. So same thing. And if this is the first one, first connection that you make is between this terminal and that terminal, no matter which way you flip the switch, these will never be connected. Right? So you know that these are the two other terminals than the common. And these, just so you know, these are called travelers. Let's see here. I'm going to label it traveler, just like the person who travels through the world, packing the bags and getting on the plane and traveler. So here's a common, and there are two travelers. So here's a traveler also, and here's a traveler also. I'm just doing this thing here because I want to get out of the way, because we're going to go do some connections here now too. All right. So usually you would have on the switch, you would have a label that says common, and that will be the common, and the other two will be travelers. Okay. Now, which way you want to position them, that switch physically after you have installed it, is going to be up to you. Whether you're going to flip it up flip the switch up and you're going to get these two connected. Oh, let me just get a better pointer. When you flip the switch one way, you're going to get these two connected, or when you flip the switch up, you're going to get these two connected, these two or these two, these two or these two. All right. So it's going to be up to you how you position that switch in the box. Usually, it's a good idea to position them the same, both of them the same. But so we're going to get something that's called a three-way switch. So what are we going to have? Let's well, we're going to have a power supply and we're going to have a load. All right, so let's draw a load. Let's have the load somewhere here. And our load is going to be a light bulb. This is a symbol of a light bulb. You know what? I'm just going to draw this thing a little bit higher. All right, let's have the light bulb somewhere here. And we're going to have a load. So load, and then we're going to have a power supply. So let's say we're going to have a hot terminal, which will be the black. We're going to have a neutral terminal, and we're going to have a ground or a bond terminal. So that bond is going to be connected to the box. Now, let's say we're going to have two boxes. This box is going to enclose this switch. This box is going to enclose this switch. And this box right here is going to enclose this light bulb, which is our load. All right. Here is every year I'm trying to find a better way of explaining the functionality of things. Now, when it comes to the real installation, there's going to be a little bit extra things that you're going to have to do, but let's get to that later. Let's get the pure functionality of having a circuit closed. What do we have to have accomplished in order to have a circuit closed? Well, the electricity, let's say we're just going to concentrate on an instant of a moment. So we're going to catch the moment that the current flows one way. Forget the alternating current idea. We don't need to worry about that. We're just going to catch the moment that the current flows a certain way, right? So the current, electric current, is going to have to flow from the hat through one of the switches and continue through the other switch and then through the load and come back to the neutral. Then we're going to have something that's called a closed circuit. Right? So when it comes to connecting and this is just one scenario. What do I mean by that? In this case, we're going to supply the power to the first switch that we have in line here in the whole system. And then the load is going to be at the other end. The other scenarios and the idea of connecting it is basically pretty much the same. There's nothing going to change. You're just going to have the wiring routing is going to be a little bit different to accommodate the same idea. Because sometimes you can have the power supplied to the other switch that is in the middle of the run, or sometimes you're going to have the power supplied to the load, which is the light bulb, and you still have to make this thing work the same way. But if you apply this principle that I'm going to show you right now, you're going to be quite comfortable connecting this system, the three-way switch system. Okay, so first thing we're going to do is we're going to connect travelers. All right, so I'm just going to write it down. Travelers, I think it's double L here. All right, so let's connect the travelers. Just get here. Oh, it is. See, my spelling wasn't it? Connect the travelers. All right. Actually, if you do it in the US, you would spell with one L, and in Canada, you would spell with two L's. So you know what? Let's get, because we're in Canada, we're gonna get two L's. So they're both spellings. Sorry about that. Okay, there you go. All right, so first connect the travelers. So we connect the travelers. Boom. And kaboom. The travelers are connected. Then we're going to have to take care of the entrance and the exit of these two switches. Okay. Then, okay, let me just, yeah. Then entrance. And exit. So connect the travelers, entrance and exit. Entrance, connect the hot to the first common. Hot goes to first common. Exit, well, the other common has to connect to the load. Okay. and then bring it home. Bring it home. Because we need to have a closed circuit. So how do we bring it home? We take it all the way. That one, it has to come back. Everything has to come back to the neutral. Okay. Get the idea of this. Here is the whole connection here. No matter how you connect this, how you arrange this thing, the power being supplied to the first switch or the second switch or the load, you're going to connect the same way. Connect the travelers, then take care of the entrance, take care of the exit, and bring it home. All right. So in this case, do we have the light bulb on? Let's see the way of the, do we have a closed circuit? That's what we're concentrating on. At any of instance of the moment, let's say the current flows this way at this time here, we're going to go from the hot to the first common. We're going to connect to here, to this thing, this terminal, and then we're going to continue that. Whoops, there is no connection. This thing is just dangling in the air. All right. Well, let's do something here. Let's flip that switch here, connect it this way. So we just click this switch. Do we have a closed circuit now? The electric current will flow through here, hit the first common, connect to this terminal, the traveler, continue to the other traveler, and oh, it's going to, there is a continuity here. It's going to continue to the load, through the load, and it's going to come back to the neutral. All right. Well, let's flip this switch this way here. As you could tell, we have open circuit now, so the light bulb is off. Continue. Do we have a closed circuit? Continue on this. Continue through that. Continue through that. Whoops. This thing is hanging in the air. We have an open circuit, so there is no connection. Right. Well, let's flip this switch now. Back to the way it was first. All right. Do we have connection? Start on the hot. Go to the first common. Go through that switch. Yes, we have a connection. Go to that one. Yes, we have a connection. Yeah, we continue through the load and we come back home onto the neutral. So this is sometimes called a stairway switch, because if you are in the basement and here is the other like first floor and you have, well, stairs here, and here is a light bulb in the basement, and here's a switch, and here's a switch. Okay. So when you're walking on the stairs, upstairs, and then you forgot to turn the light off in the basement, and your mom is telling you, did you turn the light off in the basement? Oh, oops, I forgot. I have to go all the way back down. No, you don't, because you have the other switch. So you can turn it off on this switch here. So that's any, you can control the light by flipping any of the switches. Right? So that's the idea of a three-way switch. All right. Now let's look at the conduits. Let's look at some of the wiring that is going to be involved here. The first conduit that is going to go from the power supply or from the electrical panel or wherever the branch continues, it's going to be this conduit right here. Then between these two boxes, we're going to have a conduit right here. And between these two boxes, we're going to have a conduit right here. So this conduit is going to need two conductors. This conduit here, over here, is going to need three conductors. And this conduit right here, this conduit right here is going to need two conductors. So between these two boxes, between this box here and this box here, you are going to have oops, come on, this new, between these two boxes, you're going to have that box offset that you just made, or you're making this week. Remember, here are the two boxes, and you have made a box offset. So that is going to be that conduit right here between these two boxes. Over here, we're just going to have the two screw connector, and we're going to get the 14-2 wire going in there. And over here, that little short pipe that you got together with the other one, that is going to connect this to a hexagon box, and that's where the light bulb is going to hold the lamp holder, and that's where the light bulb is going to be. Right? And this is the video that the preparation video that I have posted already in the announcements. I'm going to show you exactly, I'm showing you on that exactly how to do it. Now, what I have there is I interrupted the wires here, and I interrupted the wires here, which means we're going to have a pigtail. Everything that we have done right now, we're employing in this here. I'm just going to erase that to make myself more room. So over here, we're going to make a pigtail and join our wires with a pigtail. And over here, we're going to do the same thing. Why are we doing this? Could we just pull one wire, one straight wire from this box through that box and through the box in the light bulb? Yes, you could have done that, and it would work, but it would work when you are assembling this thing for the practice purposes, the whole system, assembling it on your counter, on the countertop, and that's fine. What is going to be done in reality, there are stages during the construction site, during the construction process. You're going to have a bunch of boxes. You're going to have a whole bunch of wires on reels in boxes and whatnot. And one of the first stages of the, well, first stage would be the laying the raceway. So first you're going to assemble the raceway, which is connect the pipe here, connect the connector, connect the conduit here, connect the conduit there, and boxes, everything is basically assembled, the raceway. Then you're going to do the next stage would be the wire pulling. So on construction side, you're not going to have these two boxes 3 feet apart. You're going to have one box in one room and maybe the other box in the basement somewhere in another room. So you're not going to waste your time on trying to calculate the length and pull the slack here and that. There's no way you're going to do that. You're going to just dig yourself right in. So what you're going to do is you're going to bring the wires to the first box, cut them, leave enough length for you to work with later on, and just tuck it in. And then you're going to run whatever wires you need. That's why you're kind of doing the provision of how many wires and what colors you're going to need. Between these two boxes, you're going to run those wires between that. You're going to leave enough length for you to work with later, and you're going to leave enough length for you to work with later. Tuck it in, continue with the wire pulling. And sometimes the wire pulling process gets few days, sometimes a month or 2 months, depending on the size of the project. Okay. And then you're going to get to the next stage, which would be termination. All right. So that's why I'm trying to get this thing for you to get just one step closer to the reality. So you're going to have to make a pigtail. You're going to have to make a pigtail and make the connection. And then we're going to use a continuity meter to make sure that the system works. All right. So we're going to flip the switch here, and instead of a light bulb, we're going to connect just a piece of alligator clip lead. We're going to short the terminals on the light bulb connection. So we have the closed circuit, and on the other side, we're just going to connect a multimeter on the continuity. And if there's a connection, if it's a closed circuit, we're going to get the beep on the meter, and we should be able to continue to control this whole system from either of the switches. Right now, so here is the idea of a three-way switch, and I gave you the simplest, the most visually simple idea of how to connect that so we get the continuity from either switch. Next time we see each other, we're going to discuss the possibilities, the different possibilities of having the wires connected to either of the boxes. So here's a power connected to the first switch of the run. Here's the run. But how would you connect things if you had the power connected not to the first box? How would you connect things if you had the power connected to provided to the second box instead of the first box? There's a possibility of that. Or how would you connect things if you had the power provided to the load first, and you still have to use those switches? Now, if you apply, so I just want you to kind of dwell on that until the next thing, but please be honest with yourself and see how you would be able to connect that in order to accomplish the same thing using this scheme here. First, connect the travelers, then take care of the entrance, which is had to common here. Then take care of the exit, which is the common to the load, and then bring it home. Bring it home, right? So the entrance would be the the first HUD to common, and then the common to the load, which would be the exit, and bring it home. Basically, you have to take the neutral out of the light bulb into the neutral here, or this terminal, the other terminal. Now, notice one thing. There is one hardwired connection that is uninterrupted, sort of, because we have those connectors, those wire connectors here, but there's no switch between neutral and the terminal on the light bulb. So we should have a neutral only, not switched, because if something goes wrong, you have the neutral here, which is basically the ground potential. We couldn't have it the other way, because if we switch the hot and the neutral here, we would have a hot here. So no matter how you can disconnect the switches here, you will still have a hot. That could be a dangerous situation. What we have here, this is a hot also going to on. So this one, this side of the light bulb or the load is neutral, and it has an electrically uninterrupted way to the neutral. See, no switches, always connected. So obviously the other side will be the hot terminal of the light bulb, but this one is called a switched hot. Okay, switched hot. It becomes hot when it is switched. So it's called a switched hot. Also, what we have to comply with the electrical code here now in Canada is, one more thing I'm going to mention that to you, is that the neutral has to be in all the boxes, whether it is used in the system presently or not. It has to be there. So in this case, we're going to do the check. Do we have a neutral here? Yes, we have a neutral passing through the box. So yes, we have the neutral supplied to the box. Next box, yes, we do have a neutral supplied to this box. Good. And in this box, do we have a neutral supplied to this box? Yes, we do. No problem. But why don't you just take a pen and paper, or a pencil and paper at home, and try to supply the power to the one in the middle, and then connect travelers, take care of the entrance, take care of the entrance, but you have to run the wires through the pipes. Try that. You're going to get it or not, just get your thinking juices when it comes to that. Then another scenario would be, try to supply the power to the load and do the same thing. Connect the travelers, take care of the entrance, take care of the exit, bring it home. So try to do that, just so you can practice, because that's what the assignment is going to be. You're going to come up with 3 scenarios, but also we're going to have some other rules, which is the neutral has to be there, and things are going to have to be drawn a certain way and labeled a certain way. Right? Okay, so this is the lesson for today, the 3-way switch. Did we mention anything about the pipes? Yes, we did mention something about the pipes. We're not going to continue with the calculations today. I think we have enough for now. And yeah, so I'm going to see you next time on Friday. And excuse me, and we're going to continue with the 3-way switch. Now, also, there is a possibility of you having to connect. For sure, you're going to come across a situation that you're going to have to connect a 4-way switch, which is the next. You're going to do that during the next term. I'm not sure who the teacher is going to be. But today, the only thing, today, during this term, we're just going to take care of the 3-way switch. 4-way switch is almost the same as the 3-way switch, but it's a 4-way switch, and that is involving, if you want to have more than 2 switches controlling the load, then you're going to have to apply something that's called a 4-way switch. Right? But let's take one thing at a time. Okay, so on a happy note, it is almost Friday. And why is it almost Friday, even though it's Monday today? I'll tell you, as I always tell you, because every day is almost Friday. And on that happy note, I will see you when I see you. Thank you, guys.